Good day. You are welcome to Biochem Science Hub. As you have known, this is the right channel for you to learn all your science-related subjects such as chemistry, biology, physics, and mathematics. So today's edition, what are you learning? We are learning another topic in chemistry, modern electronic configuration. There is no how we want to understand modern electronic configuration without now understanding the whole concept of electronic configuration. That's 288 system. If you watch our previous video on that edition, we analyze how to arrange your first 20 elements and so as other elements in the periodic table. And also you will be able to determine using this system to know which group, which period does element belong to. So like now for calcium, we know calcium is what? 20 on the periodic table, and that's what? 2882. So using this system now, I can be able to tell that my calcium belongs to period 4 and group 2. So this is easy. I said, don't forget your period is the what? Your period is the horizontal arrangement of elements in the periodic table, while your group is the vertical arrangement of elements in the periodic table. We have basically 8 groups and 7 periods in the periodic table. So the last number using this whole system, you'll be able to determine that this element belong to which was this group. Then how do you determine the period in which the element fall into? By counting the total number of the digits that you have here. Count with me: 1, 2, 3, 4. So that's period for group 2. I hope we understand that. That's on the previous topic on old method of electronic configuration. So today we'll be looking at the modern electronic configuration. In this modern electronic configuration, that's where students usually say, they find it difficult in as much to arrange they find it difficult to arrange the elements based on their energy level, because we have 1s2, 2s2, 2p6, 3s2, like that. So many students don't know how this thing follows. So this today on our edition, we are breaking everything down for you. So follow me, let's go. So we have some principles that we have to understand on this thing, and some concepts that we have to do what? We have to understand. Starting with Aufbau principle. Aufbau. This word is a German word, and it simply means what? Building up. It simply means building up. So when you remember this word, then you should be able to know that your Aufbau principle states that electron must be able to do what? Occupy the lower energy level before moving to the what? Higher energy level. So we are going to break everything down for you here in today's edition. So that's Aufbau principle. And those energy levels also, we are going to talk about them. And this modern electronic configuration has to do with quantum physics, as well as following the what? Periodic table rule. So, and we have the suborbital SP, D, and F. So X has 1, P 3, D and F is 7. So as we know that the occurring pair, this multiplied by 2, that's 2. This multiplied by 2, we have 6. 5 multiplied by 2, we have 10. 7 multiplied by 2, we have what? 14. So hope you've gotten this. So if you have gotten this, then let's go. How do we fill it? So we have S, we have P, we have D, and we have F. So don't forget, we said S is 2, P is 6, D is 10, and we have F as what? 14. So we have this modern electronic configuration basically has to do with, it's just like sub level. Like now you are looking for a student in a particular hostel, in a building. So you have to know which floor does the student belongs to. Is it floor 1? Is it floor 2? Is it floor 3? Is it floor 4? So, and after determining the floor in which the student belongs to, you have to know the wing. Are you going through the right wing or you are going through the left wing? So those are the, in a layman language. So after that, you have to know which room does that particular student belong to. As we know in hostel, two students can belong in a room, three students can even be in a room. So after determining the room, you have to know what? You have to know the bed in which the student is staying. Then you'll be able to divide, oh, the student is staying in bed 2, room 7, floor 3, like that. Hope you understand. That's everything about this modern electronic configuration. So we have 1, 2, follow me, let's go. 1, 2, 3, 4, 5. If you are finding it difficult to arrange your electron in an orbital using this modern electronic configuration, then this step is easy. This following the above principle. We have 1s2, we have 2s2, we have 2p6, we have 3s2, we have 3p6, and we have 3d10, 3d10. We have 4s2, we have 4p6, we have 4d10, we have 4f14. So let's stop at there for now. So how do we now know the arrangements of all these things? Like now, if you ask me for this element, I will be able to tell you easy as a chemistry teacher. But how do you also know it, how they follow? So that you won't misplace them for one another. So this is it. You have slanting it this way, and you are coming from the back. You are coming from the back. Don't forget, see the direction of my arrow. You are coming from the back. So let's just stop there. You know, we have another 5s. Okay, we have 5s here. So 5x, 5p6, 5d10, and 5f14. So let's stop at 5s. So now let's arrange this together. Don't forget, we are starting from the back. 1s2 followed by what? 2s2 followed by 2p6 followed by 3s2 followed by 3p6 and followed by what? 4s2. After 4s2 we have 3d10, we have 4p6, and we have 5s2. Don't forget, 2s carry the half magnum number of electron. Pair of electron as what? 2. Now this is it. We stop at this. If you want to continue, so you can continue, of course. So like that. But let's now fit in all these things in our using the first 20 elements that we have here. That is our hydrogen to what? Calcium. So let's fit in them. As we know, your atomic number for hydrogen, 1, 2, respectively, like that. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 1, that's 1x1, helium 1s2, lithium 1s2. Let's go. You can follow me. Let's do it together. 1s2, 2s2. 2 plus 2, that's 4, right? 1s2, 2s2, 2p6, 1. 1s2, 2s2, 2p2. 1s2, 2s2, 2p3. 1s2, 2s2, 2p4. 1s2, 2s2, 2p5. 1s2, 2s2, 2p6. 1s2, 2s2, 2p6, 3s1. That's 11. 1s2, 2s2, 2p6, 3s2. That's magnesium 12. 1s2, 2s2, 2p6, 3s2. After 3s2, don't forget you are moving to what? 3p6. I have to limit my handwriting so as to fit in. So 3p1. That's aluminium 13. 2 plus 2 plus 6, 10, 13. So we have 1s2, 2s2, 2p6, 3s2, 3p2. And we have 1s2, 2s2, 2p6, 3s2, 3p3. We have 1s2, 2s2, 2p6, right? 3s2, 3p4. We have 1s2, 2s2, 2p6, 3s2, 3p5, right? 1s2, 2s2, 2p6, 3s2, 3p6. So we've occupied the 3p6, then we are moving to what? We are moving to 4x. 1s2, 2s2, 2p6, 3x2, 3p6, and 4s1. Potassium. So moving to calcium, we have 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So we filled our first 20 elements using that. And if you are moving to the next element in the periodic table, you know, just follow this your what? Your rule, and only as much you know your what? How your elements follow. And you know, after that, we have your what? D block elements after that. So having known about this Aufbau principle, so we have to fill an electron in the lowest energy level before moving to the what? Before moving to the next energy level. That's about Aufbau principle. So moving to now. Hund's rule states that two electrons must be what? Two electrons in the same sublevel must be what? Must be separate. That is what that telling us. Let's use any element here. Let's use carbon. Carbon 6. You know, for carbon we have what? 1s2, 2s2, and 2p2. So filling in using Hund's rule, this is what Hund's rule is telling us. And 2p. Don't forget, this is your 1s2, while this is 2s2, right? This is 2p2. Don't forget the maximum number is 2p6. So you know electron in what and in pairs have explained to us. So filling it like this, If one go this way, 1s, this for our 1s2, this 2s2, right? So moving to 2p2, so that's what Ohm's rule is telling us. So that is, this 2p2 shouldn't be written like this. It shouldn't be written this way. 2p, just like we fill this one, now do like this for this 2p2. This basically what? This is totally wrong. That's what Ohm's rule is what is telling us. So Pauline exclusion principle. Moving to Pauline exclusion principle. So Pauline exclusion principle is basically telling us that no two electron is basically what? Have the same four sets of quantum number. They now have the same four sets of quantum number. Don't forget, in the beginning of the video, I explained what is what quantum number is. I told us that it's just like going to a school, looking for a particular student in an hostel, which floor, which wing, which bed number, like that. So let's use the carbon as the case study for that one too. So we have carbon, we have 1s2, 2s2, 2p2. So using that, don't forget I said we have floor, we have what? Wing, that's 2, and the 3 we have room, and 4 we have what? Bed number. Bed number, isn't it? So this 1s2, 2s2, so 2p2, using this floor, wing, room, and bed number. So we can say this 1s, we can say that's floor 1, isn't it? And we have wing x and 2 bed full. So this one we have floor 2, wing x, x wing, 2 bed full, isn't it? Floor 2, S wing, 2 bed full. And we move to 2p2, floor 2, isn't it? P wing, isn't it? And we have 2 beds. So that's on filling the orbital using all this rule. And some students ask, what's the X, P, G, and F? Those words are used from what? They are used in quantum physics. And S means sharp. P means principal. D means diffuse. And F means what? Fundamental. So that's about this. So you can use our assignment, you can use your own rule to fill your what? To fill your 420 element. So I hope you understand. Thank you for following us. I hope you understand better. The topic is just as easy as I said. So if there is any question, that anything that you wish that you don't understand, you can kindly DM us or ask us. And thank you for following this channel.